The last type of equation is called oxidation reduction, or also known as redox. This is a little bit harder to understand than the other types of equations, but essentially all we're going to be doing is transferring electrons from one element to another. When an element changes charges, it's either oxidized or reduced. Let's say we have some substances where we have X with a positive charge and Y with a minus charge. Let's say that X plus is losing an electron and donating it to Y minus. X plus is being oxidized. That is what we consider an agent that has lost an electron. And you'll notice that X plus becomes X2 plus on the product side after it has lost an electron. Remember that electrons are negative. So the more electrons you lose, the more positively charged you become. The Y, on the other hand, is gaining an electron, when we consider that to be reduced. So the Y with a negative 1 charge after gaining an electron becomes Y with a 2 minus charge. A good way to remember which one is being oxidized or reduced is using the acronym OIL-RIG. OIL stands for oxidizing is losing electrons. RIG, reducing, is gaining electrons. If you can memorize that, and you can tell which substance is losing or gaining electrons, you can tell which one is being oxidized and which one's being reduced. Let's go through an example here real quick. First thing you need to notice is that magnesium is by itself. When an element is by itself or diatomic in nature, it has a net charge of 0. So you can see that the magnesium is 0 on the reactant side. But since it's within a compound and paired up with chlorine on the product side, it now has a positive 2 charge. We figured that out because chlorine has a negative 1 charge. There's 2 of them, giving it a negative 2 charge, which means the magnesium has to be positive 2 to make that compound neutral. So you can see that magnesium went from a 0 to a positive 2. The only way it could do that is to lose electrons, and which we consider oxidized. Remember, OIL-RIG. The hydrogen is within the hydrochloric acid. It has a positive 1 in that compound. But on the product side, it's by itself, even though it's diatomic, which means it has a net charge of 0. In order to go from positive 1 to 0, it must have gained an electron, which we consider reduced. Notice the magnesium was oxidized and the hydrogen was reduced. You will always have one element being oxidized and one element being reduced in a redox equation. But what about chlorine? Chlorine goes from a negative 1 and stays a negative 1, which means it didn't change anything. And we call elements that don't change their charge in a redox equation a spectator ion.